Good afternoon, everyone. Is my audio is clear and my slides are changing? Please, anyone respond?
Yes, sir.
Yeah. Okay. Thank you. Thank you. So, in the last session, we have discussed a few things about the continuous integration and continuous delivery and continuous deployment in machine learning operations. So, for the next few minutes, we will recap the things we have seen in the last session and we will move on to the pipeline testing and trigger concepts. Okay. So let's begin with the continuous integration. Actually, this CI/CD it is a major part of this machine learning operations. It is it is allowing our application to automate the entire process, and also we are going to integrate the new machine learning model versions, and we can deploy them into the production in the final stage. So this automation kind of this process ensures the particular models are updated in a very quick manner and without any manual intervention, all the things are happening, right? So this is the thing we have discussed about, on the last session. And next, some kind of steps. It is steps are involved in continuous integration and continuous delivery process. Right. So in the machine learning operations, the CI/CD they are acting as a pipeline, and also it is following a clear sequence for the uh, different continuous steps. So first, we actually the data scientists push their data, and their change. The code changes the model updates and it is defining a version control system. It may be like a GIT, right? So and now the automated testing it is one kind of process. So automated testing or triggering it's one kind of process that can be pushed, and it is also does not having any braking mechanism to the barrier the functionality of the all the things. So we have seen these things in the last sessions. So here in the CACD, it is automating the everything, and they are going to make data in the data to the entire outside world to be the insightful thing. And next is the overall architecture or overall flow of the continuous integration, delivery, and the deployment pipelines we have seen. So in the continuous integration, we can do only building the model and the testing model can be done. And the continuous delivery and the continuous deployment only we can see the testing, so acceptance testing and the smoke testing, and the final we are going to make the product in the deployment stage. And these are all three key characteristics or key metrics related to the machine learning operations CI and CD. Right. So up to this we have seen in the last session. And next we are going to see about the pipeline execution and the pipeline testing. So let's discuss the pipeline execution and testing related to machine learning operations. So here we can execute the each and individual jobs automatically by clicking a create release from the Microsoft Azure portal, right? And which is again it will be triggered by the task like certificate selection and the deployment to the staging environment. So once the pipelines are created or pipelines are triggered in the machine learning operations, some downloading of the artifacts and the provisioning of the resource management, what kind of resources, what kind of machine learning model they are needing in the resources. So that should be done. And also we are going to deploy the each and every services they are executed in an automatical manner. And the third only, so after deployment of all the thing, some some type of monitoring tools are used to validate whether the pipeline was successful, and it is also ensuring that the model performs as it is expected. So this is about the pipeline execution and the pipeline testing. And next, we are going to see about some trigger types related with the pipeline. So here there are several ways to trigger the pipeline. And for instance, when a new Docker image or some artifacts are created, the pipeline can be automatically triggered. So based on the application, these kind of triggers can be created. And also additionally, some pipelines can be triggered by the GIT commands also. So they are it's used for scheduling the retraining process. So when any feedback it is recover or when a feedback is received, some kind of application program interface they calls from the external systems. So these artifacts trigger Docker schedule AP and triggers. So they ensure that these specific models are updating and the deployment in a very efficient manner. And these kind of triggers are reduces the need for manual intervention. So automatically these triggers are called and some kind of operations will be taken care. So it is also helping helping in automating the tasks such as feedback model, retraining model, and updating the system in the response of a new data. When a new data comes, these kind of triggers will be called automatically, and the insightful things will be happen. And next is about the introduction to the application programming interface and its role. And also some microservices are available to provide the interfaces in a very fast way, right? So we will move on to the API, that is application programming interfaces. So these are all, it is a kind of intermediate device and it is placed between the applications and it is also allowing them to communicate and exchange their data. Right. Yeah, right. So it is acting as intermediary between the applications and they are allowing the entire process to communicate and exchange their data. And also here, microservices, it is one kind of a simple code or module. They break down the large applications into the smaller, and also it may be a independent services and they can handle some specific function. So each and every microservices, they are having some specific functions to do, and this approach makes all the applications in a very easier to develop, and also we can scale and we can maintain the data in an efficient way. So here API, it is enabling the different software systems to communicate with each other. So here they are also used to expose the functionalities of data of a system to other application through a standardized interface. So each and everything should have some interface to work on to that. So all the processes are happen or communicated through this API. And also in machine learning, APIs are often allows applications to send request and give say and receive the response, and they can send the request to a specific model and receive the predictions in the real time. And some of the type of APIs are depicted here. So there are different type of APIs. They include some REST API and which are most common in the machine learning operation. So each and every particular time of period, some API protocols are used, and most of the API protocols are using JavaScript notation, JSON for JavaScript object notation they are using, and previously in the early stages they have used XML, and also some REST API. They are allowing the systems to integrate with their models over HTTP, Hypertext Transfer Protocol, and it is also making an very easier to integrate all the machine learning models or protocols into the web application with some other extra services also. And next is about the microservices. So as per the definition, microservices, it is one kind of architecture and they divide the large applications into smaller independent services, as I have told you earlier. And also here, each and every service handles a specific function to do, and they are also make a communication with other services using a specified application programming interface. And here, modular approach also can be used here. So here, this allows the entire teams or the working teams to work on different parts of an application in a very independent manner, and also they are making the each and every application processing in a very easier to update and scale, and also we may maintain the entire code. And next, we are going to see the comparison between microservices versus monolithic, that is a old architecture. So here, traditional monolithic architecture, they have tightly coupled with all the components of the application into the single large system. So it is this is one kind of some demerits. So here, it is very much harder to scale and update the system. Okay, and when we move on to the next microservices, in contrast to that, so here the microservices break the application into smaller things, smaller models, and that can be developed and they can tested and they can deployed independently, and it is also improving the flexibility, scalability, and the resilience of the machine learning models. And this is the diagrammatic comparison between monolithic architecture and microservices architecture. So monolithic here, the only a single module will be there, and that will be connected to the databases. But in this case of microservices, all the things will be split into a similar a different kind of functions. Microservices, each and microservices, they have their own databases to work on to that. So when here the parallel processing of the application insights can be done with the help of microservice here, because here variety of databases involved, variety of microservices for each and every applications or application models are involved. So here parallel processing can be done in an efficient way in this microservices architecture. And next, why we are using this microservice and why we are having these many ways. So here in machine learning models, microservices, they are offering some advantages over the monolithic architecture. So here each and every microservice can be scaled in a very independent manner. Okay, so all are integrated, but they are working towards the independent manner, and they are allowing the specific organization to scale the component. Okay, so we can fix, or we can vary the customers, or we can vary the users related to that model, and it's also serving our data processing based on the demand purpose only. And also here microservices are increasing the reliable one. So if one service fails, the others continue to function. So other take the operation of the another microservices, and it is minimizing the risk of system-wide failure. And here one case study is defined here. That is defined with the car repair facility, right? So here let's we can look at to the example. So imagine a car repair facility. They are using their IP-based camera, IP-based that is CCTV camera. We can use to track the position of the vehicles. Okay, so here the initial proof of concept stage, that is the monolithic stage. So here the facility might build a monolithic application. So only one kind of model will be there, and they are going to fetch the camera streams and estimate the vehicle position. And however, as a system grows, it becomes clear that microservices would offer more flexibility and scalability. So with monolithic architecture, we cannot adapt, or we cannot handle so many requests based on the applications uh, and their processing. So here we should move on to the microservices architecture. So now we move on to the, so this is the major risk we are facing in the monolithic application. So here monolithic machine learning models are very much harder to scale, because you cannot scale the individual component. So once they are fixed, we have to work onto that. For example, so if one component crashes, the entire application may get slowed down or may get signed off. So it is leading to the outages or the description of the services. And next we are moving from monolithic architecture to the microservices architecture. So here, when we move on to the particular application from monolith to microservices, we have to transform some components also, right? So here we are going to transforming from this monolithic to microservice. They are involving break down the entire system into the very smaller and the independent services. So this is maybe one kind of challenges. Okay, so for example, if the car repair facility, you could create a separate microservices for video stream collection, and in another one thing for image processing, and we have to make a vehicle position estimation. So each and every function should be worked on each and every module, each and every microservices. So here each services can then be selected and they can be maintained in a independent manner. And next we are going to see the a specific microservice component for the machine learning models. So here, each and every machine learning microservice component, they are having some machine learning. So video stream collector and some image processor and some position classifier we are having, right? So each and every models, they are having their own modules and they have to work on to that, right? So first video stream collector, they handles the video inputs from the image capturing system, and also some image processor they are used to process. They are having some machine learning mechanisms and they are having some machine learning cache memory to their image for analysis. And also we are going to make the position for the each and every images over there. So that can be done with the position classifier. And also the last step, we are going to make a receipt from the car position, and it is used for calibrating the entire facility setup, and they have to make a insightful prediction to the all the machine learning components, right? So this is about the, in this way we are going to work the machine learning microservices component in our higher manner. So first, I will consolidate all the thing. First, in this facility, we could separate the microservices, and each will be run on the each and every module over here. And also here, each and every wait. Yeah. So here this microservice based machine learning approach and its architecture, they are having each and every service perform a specific task. So for example, the video stream collector handles the incoming video feeds, and also they are having some image processing analysis methods to take the image analysis process, right? And so, and thus the position classifier, and they are estimates the vehicle position. So these services are working in the independent manner, and they are in the process of improving the scalability and the reliability. And next, we are going to see the benefits of the microservices in the machine learning model. So here, the key benefits of microservices in machine learning are the scalability, flexibility, and also the reliability, right? So here microservices can be scaled independently based on the demand. So based on the requirement or based on the user needs also, these microservices starts working, and they are going to take the process in a very efficient way. So here it is also ensuring that the each and every resources are allocated in a very efficient manner. That is the another thing. So if one services fails, the other continues to work on to that, and they are running towards the minimizing the impact of the overall system. So these are all some benefits of the microservices in terms of machine learning. And next, the role of API in microservices. So here API gateway plays a major role to provide the communication. So this microservices can communicate with each other through the specified application programming interfaces. So here each API can be acted as a gateway, and it should be a mediator between the each and every microservices, and they can be managed, and they can handle the request, and they can process the routes in a very efficient manner. So here this process decouples the entire components of the system and making it is easier to manage the scaling process in a good way. And next, we are going to see about the REST API-based microservices. So REST APIs are widely used application programming interfaces, and they are going to manage the entire microservices. And this microservices, they allow different services to integrate seamlessly with the hypertext transfer protocol, and also they are enabling some machine learning models to serve predictions in the real time. So here, in this way, we are using REST API for the microservices, and some giants, IT giants are they are using RESTful APIs. Use the Google, LinkedIn, and Twitter. They are using RESTful API for their Microsoft microservices purpose. And the REST API-based microservices, they are providing some services also. So here this machine learning model serving through the REST APIs, and they are also provide some kind of benefits. So we can serve the predictions on the fly to multiple users. So based on the multiple users, we can predict the thing, and we can scale the application by adding more instance. And also even we can combine the multiple models using different API endpoints. And also here REST APIs are separating the model service environment from the user facing environment to the improved security and scalability one. And these are all the functions or HTTP related methods used in the RESTful API. So we are having the common most methods are get, post, put, and delete. And also we are going to, if you want to work on to the database related things, you have to use the CRUD operations also. Create, read, update, replace, and delete operations we can use. And this is the code snippet. It is used for developing a microservices using Docker. And Docker, we have seen already. So Docker is a snapshot tool that makes the easier to build, package, and also we can deploy the microservices. By using this Docker, we can ensure the microservices they are running in a very consistent manner. Okay, so the each and every Docker they are having some Docker file, and this example it is they are showing how we can use the Fast API framework. Okay, so Fast API framework they can be used to develop simple microservices, and this Docker file simplifies the deployment to build the code, and this can be integrated to the microservices to do the perform perform to perform the weather related applications. And the last step here we are going to testing the API. So once the microservices are built using Docker, so the last step we are going to test the API. So we can run a Docker container in a local manner, and we can test the predict endpoint with say with the sample data. We can test the data also, and also we are going to use a method called get and post method to deploy all the process. And also next after the testing we should deploy. So after testing process, each and every application programming interfaces they are directly connected to the microservices. We and this should be deployed to the production environment. So here with the Docker file, the same container. So what's the container we have used in the all the machine learning operation process? The same thing we should use for testing, and it can be deployed to the cloud platform. Either it may be a Kubernetes cluster or some AWS server. Okay, so this is about the continuous integration, continuous delivery process in terms of the this kind of application programming interfaces and this monolithic architecture and microservices architecture.